We're going to improve the component placement, but let's set up our package-to-package spacing design for assembly rules first. After this video, you'll know how to set up design for assembly spacing rules that guide you while you're improving the component placement. So let's go to Constraint Manager under Setup Constraints. Then under Manufacturing, go to Design for Assembly Package-to-Package Spacing. I'll maximize this and then I'll move this over. Now, we want to classify all our components, so the Design for Assembly knows how to set up the rules for each component's edge-to-edge spacing, side-to-side spacing, side-to-edge spacing, and edge-to-side spacing for through-hole components, connectors, and surface mount devices and ICs. They're all slightly different for component placement according to IPC standards. Luckily, the Design for Manufacturing wizard helps us with this. So do show symbol classifications and we'll create some categories. Now, according to the IPC standard, there are a number of spacing rules and constraints optimally for component placement. The IPC standards were written a while ago, so manufacturers are able to do tighter spacing on a lot of these. But let's see, we have different categories. We have discrete through-hole devices, so we'll create DFA dev class package. We can call it discrete THD. That's our through-hole resistors, through-hole capacitors, through-hole diodes, and so on and so forth. Then we have discrete, or rather integrated ICs or integrated circuits. So ICTHD, right? Next we have, well, when you have a mix of through-hole and surface mount devices, you're going to have some slightly different rules, and that's okay. But let's get to the surface mount now. We'll do discrete surface mount devices, discrete SMDs, and we have IC SMDs. Then we also have connectors, so do create DFA dev class package. The connectors will be edge mounted more or less, and we can call them connectors. These are the edge mounted connectors. Then we have our regular connectors that are not edge mounted, like the ICSP header, although it is close to the edge, or the 4-pin header that may or may not be placed on the PCB. Now, what we do is select the components we want to put in certain categories. For instance, the ACERN HF, the capacitor. You hold down the control key and select the packages that need to go in, say, the discrete SMD group. The DIOC, that's LEDs. Fuse, that's surface mount inductor, that's surface mount as well, surface mount capacitor, surface mount resistor. The resistor is at 0603 surface mount package, varistor. Then, once those are highlighted, select the IC underscore SM, or excuse me, the discrete underscore SMD selection. See how it turns white? Then you click this arrow to put them in there. Next, let's look at connectors, just because I see it on the list here. Connectors, the 10-pin connector and the 8-pin connector, those are edge mounted. So is this other connector for power. What else do we have? The headers, they're not edge mounted, so I'll leave those alone. Okay. Now let's select our edge mounted connectors and put them over there. For the DGK8 package, that's a surface mount IC. Select that. So is the SOT23, SOT223. So we'll place those on the IC SMD. These headers are just connectors, so I'll put them in the connectors group. The jumper I'll also put in the connector group. Or actually, that's the wrong group. This needs to go in discrete, so let's take this out with the back arrow. You select the part and then back it out. Select this part again, and I'm going to place it in the discrete SMD group. For this capacitor, I missed this one. This needs to be in the discrete SMD group, and so is this STA RNC part. Put that in discrete SMD. This is the resonator that also goes in there. Discrete SMD. These two parts, well, this one's a little tricky. So the 32 pin, this is the IC SMD, place it in there. For the 28 pin, this is through hole, and this would go to the IC THD. For the connector 6 pin, that's a connector, place it under connectors. USB type 2 is edge mounted connector, place it. The X-Style is the crystal oscillator. This is a discrete SMD, place it there. The DBV, discrete SMD, place it. For the switch, it's like a IC SMD, so place it there. Finally, I'll put the vias and the mounting holes under discrete, even though technically they're their own things. Or rather yet, the mounting hole, let's make an exception for this one. Move it out. And the mounting hole needs a particular spacing. We'll consider it an edge connector. Click OK. Now we have the groups. See how the groups are organized. And then you can go in to each one of these and change these values. Like 90 mils, if we're talking about edge of the edge of the connector compared to or distance from the edge of an IC SMD or the side of an SC SMD. So I'll repeat that. The edge of the connector, see the short edge of a connector, would be 90 mils from the side of an IC underscore SMD part. I'll leave everything at the default 25 because manufacturers can put them closer now and not have many issues, but you don't want to go less than 25 mils usually. Now that our matrix is set up, let's remove some checks for now for, say, solder mask and paste mask. So let's go to the paste mask, primary. We can check for it like paste mask, but I want to turn these off actually. So let's X out of here. All changes to the constraint manager are immediate. Go to setup, constraint modes. And for my masks, I know I'm going to be good on that because my footprints are solid or are liked by Sierra Circuits or whoever your manufacturer is. But I do want to check for slivers still. For annular ring, my footprints are such that my annular rings are good. I'll turn that check off. For antennas and acid traps, do I want to check for those? Yes, I want to check for acid traps and antennas. Minimum line width? Yes, so on and so forth. For silk screen, I don't want to check for silk screen just yet. So I'll turn this off. For paste mask, I will turn this off, this check. And it looks like everything. So click apply and click OK to turn off some errors that just make things very fuzzy, very messy. And if you want, you can even go to your setup colors and turn off the reference designators for the components to make it even cleaner. It's totally up to you. I might turn it back on, I might turn it off. It's up to you. Go ahead and click Save. Yes. And while that took some time to set up, the DFA or Design for Assembly spacing rules help us do Design for Assembly in real time and not after the fact. IPC guidelines for spacing are very helpful because it minimizes potential assembly defects often caused by otherwise poor placement and spacing errors. Applying the IPC guidelines manually would be very challenging, so it's very convenient that OrCAD helps us do this automatically with Design for Assembly rules.